All right, let's do number 2. A force F applied to an object of mass m1 produces an acceleration of 3 meters per second. So let's just draw this. You have an object, and this is the object 1, so let's call it this F m1. And this produces the acceleration at 3 meters per second square. Actually, let's just draw this force only. So let's just draw it like this. Now, this could be any direction, but we're just going to pretend this is linear because this doesn't really specify. And also, if you recall, F equals ma. So what this means, folks, is that the direction of the acceleration is the same direction of the force. So, but we're just going to pretend it's linear. The same force applied to a second object of mass m2, so we're just going to call this m2, produces an acceleration at 1 meters per second. All right, so the question is asked, what is the value of m1 and m2? So we don't know what, we're not given m1 and m2, but we are given that there's some force applied to some mass, and it produces 2 results. Well, if you were perceptive, so so to solve this, let's just say that the force 1 equals m1a1, or the force 2 is equal to m2a2, because this is what we're given. We're given a1, a2. We're not given these masses, but we're not given the forces. But we do know that these forces are the same. So F1 does equal F2. So let's just set them equal to each other. So because these forces are the same, we can say that M1A1 is equal to M2A2. Because why not? In fact, that's what they're asking. What is the ratio of the value between M1 and M2? So M1 divided by M2 is equal to A2 divided by A1, or 3 meters per second square divided by 1 meter per second square, all result in the ratio of 3:1. So the answer for part A already, the result of M1 divided by M2 is going to be 1/3. So that's for part A. Now the question is for part B. If M1 and M2 are combined into one object, what is its acceleration under the action of the force? All right, how do we even... Well, let's just think of this logically here. We know that F, whatever that force is going to be M1 plus M2 of the A. There's apparently 3 unknowns here. All right, so I don't even know how to solve this. I know I solved this before. So what is if M1 and M2 are combined to one object, what is its acceleration under the action of that force M1 and M2? Oh, we do know how to solve it. Okay. So recall that we just solved for the ratio between M1 and M2. So I'm just going to write this as 3M1 equals M2. So we can replace this in terms of N1, and we can also replace this in terms of M1. So let's just say that M1A1 is equals to M1 plus 3M1 over the A, and there's your answer. And you can do it the other way. You could also say that M2A2 is equal to a third of M2 divided by 3 plus M2 over the object of A. And I bet you folks that if you solve it either way, either of these ways, the result would be the same. But notice one thing. Notice that the M1s cancel. So here, once you do the math, you realize that A is equal to A1. I'm going to go a little too fast here. 1 plus 3 is going to be 4, so it's going to be fourth of that. Is that right? I went a little too fast there, but there you go. But let's find out. Let's find out. This would be a 3 over 3. This 4/3. So let's write 4/3 A equals A2. So A would be 3A2 over 4. The results should be exactly identical regardless of what you get. So let's see if it is. All right, this is where my teaching skills are starting to suck, but that's okay. So the acceleration of A1 is going to be, what was A1? I'm going to write that down. A1 is going to be 3 meters per second square. A2 is going to be 1 meter per second square. So 3/4. Oh yeah, they're the same. Okay. So for part B, however you want to solve it, or however you want to approach this, either way works, is the result of 3/4 meters per second square. Because you put a 3, you get a 3/4. A2 is 1, so well, you can read it from there. So anyways, folks, I hope this helps. All right, goodbye.